Assalamualaikum. My name is Muhammad Zivati bin Johari and I will presenting about the objectives and introduction. First, the objectives. It is to understand what crystalline solids are. Secondly, to explain how particles are arranged in crystalline solids. Thirdly, identify common types and example of crystalline solids. Fourth, describe basic properties of crystalline solid. And lastly, explain why crystalline solids are important in daily life and technology. Today I will be presenting about the introduction to crystalline solids. So what is crystalline solids? It is a solid material in which atoms, ions or molecules arrange in a regular repeating pattern throughout the substance, forming a crystal lattice. So there are four types of crystalline solids. Firstly, the ionic crystal. Secondly, the metallic crystal. Then the covalent network, and lastly the molecular crystals. Firstly, we have ionic crystal. It consists of alternating positively charged cations and negatively charged anions. Then ions may either be monoatomic or polyatomic. It's also formed from a combination of group 1 or 2 metals and group 16 or 17 non-metals or non-metallic polyatomic ions. The properties of ionic crystal is in solid, doesn't conduct electricity except when molten or in aqueous solution. Then have high melting point. Lastly, it is hard but brittle. So the example of ionic crystal is NaCl. So we can see that NaCl have that have alternating positively charged and cations and negatively charged anion from the figure below. Then we have metallic crystals. Metallic crystal is a metal cation surrounded by a sea of mobile valence electrons. These electrons are also known as delocalized electrons, do not belong to any one atom and capable of moving through the entire crystals. The properties of metallic crystal is it is a good conductor for electricity, have high melting point and boiling point, and very ductile. The example for metallic crystal is copper. So you can see the example of the copper, the metal ions and the localized electron exist together. Then we have covalent network. Covalent network consists of atoms at the lattice point of the crystal. Each atom being covalently bonded to its nearest neighbor atoms, and the covalently bonded network is three-dimensional and contains a very large number of atoms. So the properties of covalent network is that it doesn't conduct electricity, but it has high melting point and boiling point. Then it is hard but brittle. So the example of covalent network is diamond. Lastly, we have molecular crystals. Molecular crystal is consists of molecules and the lattice point of the crystal held together by relatively weak intermolecular. The intermolecular forces may be dispersion forces in the case of nonpolar crystals or dipole-dipole force in the case of polar crystals. And the lattice point are individual atoms rather than molecules. The properties for molecular crystal is it is poor to conduct electricity and it has low melting and boiling point. So the example is the ice crystals.
Hi, my name is Ahmad Ifandani, and I will talk about physical properties in diamond and graphite. So, for the first one is physical properties in diamond. A diamond is a mineral composed of pure carbon, known as the hardest naturally occurring substance. It is a popular gemstone valued for its hardness, brilliance, and sparkle. The melting point is diamond has a very high melting point, almost 4,000 degrees C. Very strong carbon-carbon covalent bonds have to be broken throughout the structure before melting occurs. For the hardness, it has very high hardness because each carbon atom is strongly bonded to four other carbon atoms in a three-dimensional structure. The scratch hardness of diamond is assigned the value of 10 on the Mohs scale of hardness. The conductivity, diamonds have high thermal conductivity, but they do not conduct electricity. Diamond is an excellent conductor of heat due to strong bonds and tightly packed atoms. The next one is physical properties in graphite. Graphite is a mineral form of carbon. It consists of carbon atoms arranged in widely spaced horizontal sheets of hexagonal rings. Melting point. Graphite has high melting points due to strong covalent bond between carbon within each layer. In order to melt graphite, it is not enough to loosen one sheet from another. We have to break the covalent bonding throughout the whole structure. For the hardness, graphite is very soft with a Mohs scale hardness of 1.5. Graphite very soft because the individual layers of carbon atoms are not as tightly bound together as the atom within the layers. Conductivity. Graphite is a good conductor of electricity because it has delocalized electrons that can move freely. If a piece of graphite is connected into a circuit, electrons can flow throughout graphite from one end to the other.
Graphite adaptability makes it an invaluable material across numerous industries. So these are the example of industrial application of graphite. And the first one is aerospace, used in rocket motor nozzle and heat shield. And the second is metallurgy, essential for mold and crucible. And the third one is electronics, found in battery, fuel cell. And the last one is machining and manufacturing, provide lubrication and durability in high friction environment. And this is the pie chart of uses between natural graphite and synthetic graphite application in 2024. Natural graphite is mainly used in production of batteries, especially lithium-ion batteries. Its high conductivity and layered structure make it ideal for battery anodes, supporting the growing demand from electric vehicle and energy storage system. Synthetic graphite, on the other hand, is primarily used in the production of electrodes. These electrodes are essential in electric arc furnace for steel manufacturing and recycling, where high purity and consistent performance are required. Application of graphite. And the first one is graphite electrode. The largest end used for primary synthetic graphite is in production of graphite electrodes. These can handle very high current and are produced by molding synthetic graphite into the correct shape. Graphite electrodes are used mainly in electric arc furnace (EAFs) or for the production of steel, iron, and non-ferrous metal. And the second one is refractories. Graphite additives are used in the production of refractories material for high temperature environments such as the lining for furnace, kilns, and incinerators and reactors. Graph, uh, what can graphite do is increasing the thermal conductivity, decreasing thermal gradient between the hot and cold phases of the product, thereby reducing expansion and repelling molten slag. And the last one is battery. Graphite is used in battery to improve electrical conductance while remaining chemically inert and stable against corrosion. In lithium-ion batteries, graphite is a main constituent of the anode, acting as the host for the lithium ion.
Assalamualaikum and hi. My name is Muhammad Ammar bin Hafizi, and today I'm going to talk about application of diamond. The first application is jewelry. The classic stone in engagement and wedding rings, diamonds are deeply associated with the bridal industry and stand for unending love, and devotion. For the second application is windows. Diamonds are very durable to heat and are transparent. Diamond windows are made from thin diamond that are used in cover opening in laser and vacuum. For the medicine, diamond has potential for health because of nano diamond that may use for cancer medication to allowing doctor monitor the progression of the cell. For the last application is engraving. Diamonds are used in engraved hard stone like granite, jade, lapis lazuli, and topaz because high hardness and wear resistant that durable engraved lines.
In summary, both diamond and graphite are solid that exist as allotropes carbon, and their atoms are held by a network of covalent bonds. Allotrope of carbon means that the structural forms of the same element in the same physical state, but different in the physical properties and chemical properties. So in this table shows that the difference of diamond characteristic of diamonds and graphite in terms of the atomic arrangement for diamond. Each carbon atom covalently bonded to four other carbon atom, giving arrangement in tetrahedral. So we know that tetrahedral is one of the strongest geometry, molecular geometry. And for graphite, each carbon atoms covalently bonded to other three carbon atoms, forming six membrane that form a flat layer that held loosely by van der Waals force. So it effect on the next characteristic of their hardness. For diamond, it's very hard, and graphite is softer. In terms of electrical conductivity, diamond is insulator since all the carbon atom is bonded, while graphite is conductor since it has a free moving electron that can carry charge. And next is the melting point. Diamond is high and graphite is almost same with the diamond but a slightly lower. And lastly, we have uses of the materials. For diamond, we have grinding, tool for cutting, drilling, and in medical, some of medical we have used in surgical tools for diamond. However, for graphite, we usually commonly use in pencil, lubricants, battery, and automotive like brake pads since it has good heat resistance and friction. So the comparison of this crystalline solid help us to learn that their mechanical properties are influenced by the different atom arrangement in the crystal structure. Understanding this characteristic is important, especially when we want to furthering our studies in material science and application in the industry.